Hi, welcome to the second of 3 videos on integrating and taking derivatives of natural logs and stuff like that. This one's on integrating logs. It's a bit of a short one. If we have y is equal to the natural log of x, which is ln x, that means that we have e to the y equals x. They're the same thing. And e to the ln y, well, it's great because e and ln are kind of inverses of each other, so they kind of cancel out, so it just becomes y. If y is greater than 0. If it's not greater than 0, that's another class. We don't get into that at high school at all. So if ln and e are inverses of each other, that means if we just multiply them, they must equal 1. And then if we have the natural log of 1, it's actually equal to 0. And how do we know that to be true? Because anything to the 0 exponent is equal to 1. And e to the 0 is 1, so there we go. So if we have log with the base e of 1, it's equal to 0. Okay, so with these ideas, we can start using it in our problems, which are, if I have ln x equals 13, I want to solve for x. So what we can do is we can put both sides to exponent e. And as long as we do one side and the other the same thing, we're golden. We can do that. So we just put it to the exponent. Oop. Both sides to exponent. But we just said earlier that e to the ln y is equal to y, that the e and ln cancel out. So here, e and ln cancel out, which is why we put both sides to exponent e, because the x comes down, and well, x is equal to e to the 13. Oh, nice. Another one. Example 2. Okay, well, now I've got e. It's e to the 5 minus 3x equals 10. So I guess what we have to do is introduce what the inverse of e is, which is the natural log. So if we natural log both sides, all right, ln e, I guess too much too soon there. ln both sides, well, ln and e are inverses of each other, so they cancel each other out. And what happens to the exponent? Well, it just drops down. So we have 5 minus 3x equals ln 10, and then we're just solving for x, which of course would be minusing 5 and dividing by negative 3. So x would equal negative ln 10 minus 5, or you could distribute the negative through, and that's fine too. But for me, either or, I'm happy with. Then other things we can do is express as a single log. So what you got is something that it's okay, it's all that, but I want to express it as a single log. So okay, from our properties from the last lesson, if it's addition, that must mean we're multiplying them. Oh, I missed the first one. That 1/2 in front of the ln b, well, that's the exponent. We better take that up. Now it's addition, so that must mean we're multiplying them together. And you could leave it like that, which is great. But of course, if you want to be extra sweet, and I know you guys do, switch that 1/2 into a radical. And away you go. Like I said, this is a short one. That's it. In your duotang, there's a page that says 3.75, number 3, 4AF, and 6, and it's actually on the sheet. And I hope this works. Down here. Yep, 8.3. Oops, I don't need to be shouting. But I guess I am. Can't type, though. Logarithmic functions is the sheet. Okay. Back right away.